I'll allow it.
Here you go.
All right. So quiz 3 you have taken. And
No, look. My work looks like this.
Where's the factoring?
No, I did that. Look.
so see, on the one hand, I want to take. I should make problem 1 worth more points, so I could actually take points off for each like little subpart, because like some people didn't calculate the discriminant, other people didn't factor, other people did violence to the graph. I mean, there's
What? They punched it.
there's a. You guys are great believers in diversity. There is a diversity of errors in the solutions that I saw, but it's okay. Anyway, so if you compare the points taken off yours with the points taken off a neighbor, it probably won't make sense. I just tried to do something, and my grading is not uniform on problem 1.
Violence to graph, threaten it with a match.
See, he felt bad for me because he was, hyping you up. Trash talking me, so.
So in any event here, if we complete the square, then it reveals where the vertex is, which is 3, 2, or rather 3 minus 2, and consequently we can graph from there, and then I think I usually plug in a couple more points just to set the scale of the graph, give or take, and so there's any questions about problem A, problem 1, part A? The part B, if I complete the square, I get this, which shows me the denominator, the vertex is at 2, 1. And of course, the discriminant here is minus 4, which goes to show you cannot factor it over the reals. But I can use the y-intercept of 5. That's easy, low-hanging fruit to graph the thing. So, yep. So if you got this wrong, or you lost a point, please, go back, look over mission 4, problem 1, right? The first problem in your last homework, I think, was 3 of these, right? It's pretty much the same question, so if you're missing something there, try to fix it, okay? Now, for this one, let me address some common misconceptions. So I saw some people just multiply by 10 because they thought if they put 10 in the front, that would make the y-intercept 10. That's not how it works. Also, you can't just take this formula and add 10 to it. That doesn't work either because this function is not 0 when x is equal to 0, right? Whatever you're doing to the formula, you must have that p of 0 is 10. When you write the formula like this, that ends up meaning that minus 3 times 4 times a, or minus 12 times a, has to equal to 10, which then in turn tells me that a is equal to minus 10 twelfths, or minus 5 sixths. And then if you multiply it out, it looks like that, right? So as a double check, if you multiply minus 5 sixths times minus 12, you get minus 2 times minus 5, which is 10. So like the constant term here is 10. If you have written your polynomial in like standard form, yes, the constant coefficient has to be the y-intercept, but it has to be in standard form before you do that, and that's why you guys are wrong. Some of you just add 10. And some others just wrote like minus 5 sixths times x minus 3 times x plus 2 squared. That's great. There was a common error of dropping the square on x plus 2 on the answer. I didn't take off points for that, but I should have. But I didn't. So, yeah. Thank you. Yeah, you're welcome. But do be careful about that kind of thing. At the same time, I'm glad you showed work because it allowed me to feel like I didn't need to take points off there. Okay, so problem 3. Find p of x, which has the graph shares the same shape and x-intercepts. I think the dominant error I see in student solution is they're doing something with the hump in the middle, like that introduces an x squared. And that just is not the case. Like, there's not sufficient information to figure out anything about the hump except that it's there somewhere. So basically, it's just x plus 4 squared from that, x minus 4 squared from that. That's all you got. Can the test have questions like this? Yeah, sure. I mean, I would expect it. If it's on the quiz and it's on the homework, odds of it being on the test are pretty high. 70% of it? But the thing is, if I made 70% of the test like this, there's 30% of the class I would fail.
Really?
Yeah. As long as you're not in that 30. Now, I grade both sections at the same time, so I may be speaking to students in the other section when I say that. I don't know. This one here, again, you know, the dominant error I see is people inventing factors to address the maximums and the minimums. But like, that's not how it works. You just have to have, you know, you address the zeros, -6, -2, 4, that's all that you know. And you can create those zeros, those crossings, by correspondingly putting x plus 6, x plus 2, x minus 4. Each one of these factors is respectively 0 at x equals to -6, at x equals to -2, and at x equals to 4. So. This one here, be careful. Some of you didn't answer the question. Like, some of you just factored like this, but didn't tell me that the zeros were 2 and -2. I don't think I actually said to factor, so if you didn't factor, I didn't take off points as long as you had the zeros. But beware, if I change the instructions a little bit on the test problem, then you would actually need to factor. So, you know, I guess what I'm saying is, and this is very shocking advice, read the instructions to the problems as you do them.
It's harder than what it sounds like.
It is harder than, it really is. Where I used to work, there was this lady who taught calculus when I got there, and she was a bit of a curmudgeon. I mean, a curmudgeon.
Never heard of it.
Really? She's set in her ways. Set in her ways. But I had a student I taught who got a B in her class just because she's just so picky. Just so picky. And so she would, at the start of most semesters in like this class, if she teach this class, she'd given an assignment that had problems on it, right? But the top sentence was just write your name, turn the paper over, you're done.
Oh, yeah. I had that one higher.
Yeah.
I thought that's what was happening Friday. I was turning in my quiz.
Oh, yeah?
Asking if there was some mistakes.
Oh, you thought that was me punking you guys? No, yeah. It was just the printer punking me. The missing page.
We're going to go over that missing page. Right?
Oh, we are going to go over the missing page because, well,
It looked like it was the hardest.
I can extrapolate from grades. I mean, I can extrapolate from things I saw and the work that you did that there is a significant percentage of the students here which would have had, you know, 20% less credit probably if that page had been part of the actual quiz. So you could have an A++ with stars on top with this quiz and still be in serious jeopardy for the test if you don't address the questions on that page that we skipped. Sorry about that. But again, I blame the humidity in bib graves. So this one here, factoring by grouping. So I noticed that I can pull an x squared out of the first two terms, and I can pull a -4 out of the last two, and get x squared times x plus 1 and -4 times x plus 1, which then gives me x squared minus 4 is x plus 1. But we're not done, of course, because then that factors to x plus 2, x minus 2, which of course then reveals the zeros of the polynomial are 2, -2, and -1. So there you go. Problem 6, completely factor over the reals. So I give you a hint, f of I is equal to 0. That is tantamount to telling you that x squared plus 1 is a factor of f of x. Remember, more generally, the rule is what? If you have f of alpha plus I beta equals to 0, that data tells you that x minus alpha squared plus beta squared factors f of x. So that's something that should definitely be on your formula sheet, right? But not just that. It should be in your heart. You should hardwire this fact into your, I don't know if that really helps or not. This chalkboard is very chalky. Anyway, f of alpha plus I beta equal to 0 implies x minus alpha squared plus beta squared is a factor of f of x for a polynomial. This is nothing I haven't told you before, but I'm just telling you again. So great. So you can do long division to factor it out, or you could do some other method if you have one. I use long division, x squared plus 7x plus 6. And of course, then this guy factors into x plus 1 times x plus 6. Incidentally, this is the quadratic I meant to put in problem 1 on this quiz, and I just messed up. My dyslexia of flipping numbers. It's not really dyslexia, it's just carelessness. But anyway, if you want to label it something, feel free to. Use the rational roots theorem to list all possible rational zeros. So factors of minus 2 divided by factors of 3 gives us plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 1 over 3, plus or minus 2 over 3. Them's your choices. So there are these 8 distinct roots. Some of you included like, I got a quarter in one paper. I got 3 minus 3 in others. So like, not a big deal, but you want to fix that. I mean, let me say it this way. If you come into the test 3 completely clueless about the rational roots theorem, you could still make an A if you had everything else buttoned down. If you come into the test 3 not having clarity about factoring, I will destroy you. So, I mean, I don't want to, but it's going to be what happens. So, actually, I will not destroy you. You will destroy yourself. But I would like for none of that to happen. So, if you're having trouble factoring, try to think about what it is that's getting you, and like, don't do that again, whatever that is. Talk to a tutor, talk to me, talk to somebody. Yeah. Now here, rational roots theorem. So this one is nicer because the leading coefficient is 1, so like it's just factors of the constant coefficient divided by plus or minus 1, right? So that basically just leaves me the choices plus or minus 2, plus or minus 5, or plus or minus 10 as possible zeros. And when I try it out, 1 and minus 2 and 5 are actually the zeros. And so there it is. Any questions? You guys can jump in. Got any questions? Is this the one that was missing? Man, this is the. See, then this is the best page. This is like my favorite page of the whole quiz. I'm so disappointed. It's unreal. I was thinking about things being unreal. I should go on. It's here x squared times x squared minus 4x plus 5. I factored out the x squared, right? And then for this, I can complete the square. and I get x minus 2 squared plus 1. At that point, I go, aha, this means complex, because it's squared plus 1. So that gives me x minus 2 plus I times x minus 2 minus I. So incidentally, by the way, this is equal to what? X minus alpha plus I beta times x minus alpha minus I beta. This is also something that deserves a spot on your formula sheet, right? And I think when I first wrote these things in class, writing them with alpha and beta, I remember there was snickering. There was, he doesn't actually think we can understand this kind of, that's always what I read into snickering. Of course, it may be something more about like, you know, that person wore those shoes this day or something. I don't know. I don't know what you guys actually snicker about, but I do think students can understand this, and I think you need to. So the other pattern is this, right? If you complete the square and it looks like this, then you don't need complex numbers, right? It's just, this is the fact, this is the pattern. And that's almost it, right? What's the other possibility? There's really only one other flavor choice, which is that when you look at the polynomial, it's already just a square, right? So beta is 0. So either you can find a positive beta such that it's x minus alpha plus beta squared, or it's x minus alpha minus beta squared. That's what happens. And either it factors over the reals like that, or it factors over the complexes like that. I mean, technically this is also over the complexes, because every real number is also a complex number. But, you know, in this language we say this is a real factorization. Of course, technically it's also a complex factorization, but you know what I mean. What's that? Do I? Well, I could be more pedantic, but I don't think that would help anyone. Let me zoom back in here. All right, so what's that? When is the test? 12:20 to 1:10. 47 hours and I want to say 33 minutes, something like that. Yeah, less than 2 days. 2 days from now. Wednesday. About 48 hours, yeah. I was trying to give a more precise answer, but anyway, soon, and very soon. X squared times x minus 2 plus I, x minus 2 minus I. And then, of course, this one, it is a quartic. It factors x squared minus 6 times x squared plus 1. And so x squared plus 1 factors into the x minus I, x plus I, right? Here alpha is 0. And so the beta squared is just, well, beta is just 1 in this context. And here, of course, minus root 6 plus root 6. Oh, look, key facts. Why did I didn't even need to write them up here. They're already written there. I'm a dummy.
The more you know.
That is true. The older I am, the more I know I'm a dummy. Let's see here. Well, actually, before I go on from that, any questions? So, like, given any polynomial, you can always factor it into a product of linear factors and a product of quadratic factors, which are irreducible, right? So if you have complex numbers, you can always break it down into a product of linear factors. I say that with the caveat that it may not actually be pragmatically possible to achieve that for a given formula, because the actual process of factoring requires unmultiplying polynomials, and that may require understanding of numbers that is not from the given formula. Like, it's hard to unmultiply things. But the questions I will ask you will be like ones I've already shown you. And so there is hope you should be able to see how to factor it, either using the completing the square technique or factoring by grouping or something. Or sometimes I'll just give you a piece of information, like f of I is equal to 0, right? That tells you x squared plus 1 is a factor. And so, like, if you have information like that, you can kind of use long division to figure out what the cofactor is and kind of work backwards. But I will admit that, in general, the actual process of factoring an nth order polynomial is a difficult problem that is algebraically impossible for some polynomials. You need something more than algebra to do it. But anyway, so here, solve x cubed minus 4x squared plus 3x greater than or equal to 0. So I factor in x out, and then it's this, pretty easy quadratic that you've been able to factor since like algebra 2 or whatever, right? X minus 1 times x minus 3 for this one. And so I have critical numbers 0, 1, and 3. That's the places where this expression can change signs. And so I plug in some points and I get minuses and pluses and minuses and pluses. I get a sign flip at each 0 because these are odd powers, these first power, right? And so if I want that greater than or equal to 0, I need between 0 and 1, both included, or beyond 3. 3 included as well. Does that make sense? Yes, no, maybe so. Here's another one. X plus 4 over 3x minus 8 less than or equal to 0. Say write the answer in interval notation. Say, okay, so x equals to minus 4 makes the numerator 0, right? And oh no, do over. Let's see here. Sorry. See, now I'm going to have to edit the tape. I need a mulligan on my cough. I use my hand instead of my elbow, You should all shame me. Right? No? Isn't that what we do? We shame each other? We fail to follow the rules? It's really kind of an old idea. I don't know. Anyway. So the point here is 8/3 is what makes the denominator 0, right? So we have to avoid that because that would give us division by 0. So essentially what I'm saying is if you have a rational expression and you have it less than or greater than to 0, you want to factor the numerator, factor the denominator. That will show you where those two things could be 0, right? And those are potential places where this expression can change from plus to minus, right? And so I make a sign chart with minus 4 and the 8/3. I plug in some points. Like if you plug in 0, which is in here somewhere, it's easy to see you get 4 over minus 8, which is minus a half, which is what puts us minuses here. And then again, these are even. I mean, you see these are, it's not like x plus 4 squared. These are not even powers. They're odd powers. So I know it's going to like flip signs when I go across these zeros. So I got minuses to pluses and minuses to pluses over there. So in short, the solution here should be minus 4 to 8/3. I have to exclude the 8/3 because, again, I would have division by 0 if I did that. So that's how I do this problem. Sorry you didn't have the chance. Don't worry, I won't make that. I will, but the thing is, I'm pretty sure there will be stuff like that on the test. Yeah. So we can look at the mission again. There's other problems on the mission, right? In fact, that last problem was an easier version of a mission problem, right? So this one here, there is about 10% of the class that can do this really correctly. Maybe 10%. there's a lot going on here. First of all, I noticed that like degree 2, so like the numerator and the denominator both have degree 2, which shows me I can compare like leading coefficients, which are 2 and 1, to get the horizontal asymptote of y equal to 2. Here's the proof of it, but like you don't have to, like this part is just me explaining. That's not, if you didn't write that down, I wouldn't take points off. Like just recognizing that y equals to 2 is a horizontal asymptote is enough in my book for you guys. But then consider that if we can factor, you can factor 2x out and x minus 4 from this, 2x times x minus 4. And the denominator factors is x plus 6 times x minus 4, right? So this and that are common. They cancel out. That goes to show you that there's a hole in the graph at 4 because we have the same power of the factor on the numerator and the denominator. So there's a hole in the graph at 4. And the reduced function here is 2x over x plus 6. So that's going to tell me where the hole actually is in terms of y. So 4 comma reduced function of 4 gives me where the hole is, which is actually 4 comma 0.8. So 0.8 is where that hole is in the y, and it's at x equal to 4. Now there's a vertical asymptote at x equals to minus 6, right? Because we have x plus 6 in the denominator unopposed by anything in the numerator. And there's a 0, an x-intercept at 0, because we've got this 2x in the numerator unopposed by anything in the denominator. So we've got a 0, we've got a hole in the graph, we've got a vertical asymptote, we've got all the interesting players are here. And then I just plugged in some more points just to make my graph pretty. And here it is. So I got my hole in the graph at 4 comma 0.8. I have a vertical asymptote at minus 6. I've got a horizontal asymptote at 2. And I plugged in a couple of points. Here's my 0 at 0. And I plugged in like f of 8, f of 2, f of minus 4, and also f of minus 8, just to give my graph more scale, to make it more true to scale. Now, once you look at this graph, you should be able to figure out what the range is. Right? The range is the set of possible y values in the graph. So if you look at it, if you go far enough out here, you get arbitrarily close to 2 from below. And if you go far enough out that way, you get close and closer to 2 from above. But we never get to 2. So 2 is not in the range. And also, see this? There's nothing also hitting the hole in the range. So the range is all real numbers except for 2 and 0.8. That's the answer to 13. So there's the formula. Well, there's not the formula, but there's the interval notation version of what I just said. From minus infinity to 0.8, and then from 0.8 to 2, and then from 2 to infinity. In set builder notation, that's x, such that x is not equal to 0.8 or 2. And 2, I should say. Any questions? So I gave about half credit to people who did something half kind of half right. So, hey, I'm happy to have an attempt there as opposed to nothing. I understand there's a lot to learn, but I do think it's possible for everyone to get that problem when it's on the test. Let's see here. So mission 4, right? So these problems are very much like the quiz, right? In fact, these are harder versions of what was on the quiz, aren't they? Let's see here. Let's see here. Do. In fact, this one is pretty much identically the last one, isn't it? Just there's a 2 different, right? And I guess I didn't ask about the range, but I spared you, like problem 67, I was like, no. Not for the quiz or test. No good can come of that one. Problem 68 is a good example. Like if you're, so, if you don't feel confident about this page which was skipped, you should, of course, look at, how this problem is solved, right? Like to solve this inequality, we make it into a inequality involving 0, and then we work on factoring the polynomial. I use factoring by grouping for this one. And then once I do that, I can see 2, -2, and -4 are the places where I can change sign and make my sign chart. And then from there, I can read off the solution, -4 to -2 and 2 to infinity. So there's that problem's a good example. This one right here is also a good example because I almost put this on the quiz, like I'm still on the fence about whether or not I should put this one or the 0 one on the test, If I put 0 here, then all you got to do is look at that until x equals to 3 and x equals to -5/2. Those are the places where it could change sign, right? But if I've got greater than or equal to 1, I have to combine these to get a inequality with respect to 0. Because 0 is where we make the sign chart from. Right? The sign chart is motivated by a problem that is based on 0, not 1. And so I make a common denominator. And when I make a common denominator, you find out something can flip at, x equal to -8 and x equal to, well, the denominator stays the same, -5/2. So solution ends up being -8 to -5/2, not included. But definitely problem 69 is what motivated me to put that problem on the quiz. And, problem 70 is, I think, still a fair test question, right? I mean, so. And I mean, the same is true for 71. Like a lot of you got 71 correct on the homework. So. Or something like 71. I mean, we can always, what I'm trying to say is inequality questions can be disguised as questions about what's the domain of the function, right? Where it involves an even root. Or when is one graph above another, These are two other ways I can ask an inequality question without just asking the inequality directly. So, yeah. Any questions? What is that? Is that like another little chalkboard? What is that? Oh, it is a little chalkboard. Huh. Funny. Actually, I'm kind of bored with this material. Should I put some of the exponential and log stuff on the test? No? Oh.
That's for the final, right?
My boredom is not your boredom? No. Okay, fine. I guess it can wait. Any other questions? So,
There isn't a quiz for, is there?
that's a good question. No, there's no quiz 4. I just have 3 quizzes. I think there was a quiz 4 before, but then after Thanksgiving after Thanksgiving unschedule happened, I said, proctoring exams or quizzes over Zoom for classes of more than 6 does not give me joy. So we need to do it for the final. It's a necessary evil, but beyond that, I'm trying to avoid it. So what we'll probably have the 30th and the 12th of 30th of November and the 12th of December is just like most likely either I'll post a video if I don't have all the material covered, or I'll have a Zoom help session one or both of those days. So obviously, we're not meeting in person after Thanksgiving, so something like that has to happen. Anyway, I think that's it for today, so I'll shut it down. Hope you guys do good on the test. I think you can.